Annuity concept enable people to plan for the future in terms of investment of saving. What is annuity? Annuity is a series of equal payments made at equal intervals of time. For example, shop rental, insurance policy, annual dividend, and installment payment. Equal payments are deposited or paid periodically over the time. Annuity is divided by two, which is the future value of ordinary annuity and future value of an annuity due. For ordinary annuity, the future value as of an annuity of n payments of R dollars each paid at the end of each investment period into an account that earns at the rate of I per period. So, this is the formula that we could use to get the answer. S, which is sum arising in the future, equals to R times 1 plus I raised to the n, which n is number of interest-bearing periods minus 1 divided by I. For annuity due, the future value S of an annuity due of n payments of R dollar each paid at the beginning of each investment into an account that earns interest at the rate of I per period. The formula is S, which is sum arising in the future times with 1 plus I times 1 plus I raised to the n, which n is number of interest-bearing periods minus 1 divided by I.
Hello everyone, this is example 1 for future value of ordinary annuity. Farah invests 150 ringgit every month in an account that pays 7.2% interest compounded monthly. So how do we know it's annuity case? 150 ringgit every month is referred to periodically payment. Which is similar to R, that means periodic payment. Next, 7.2% interest is our nominal rate. And compounded monthly means our frequency will be 12. Or M will be 12. Then find the amount in the account after 9 years. 9 years is our T, which is time period. First, we take out all the information that we got from the question. R is equal to 150. Nominal rate is equal to 7.2%, which is 7.2 over 100 is equal to 0.072. M is equal to 12 and T is equal to 9. To find sum arising in the future S, we need to have all the information in the formula, but I and N isn't here yet, so we need to find it first, which is I is equal to R over M equal to 0.072 over 12. And N equals to M times T, which is 12 times 9 is similar to 180. Then we can fill in the formula as equal to 150 open bracket 1 plus 0.072 over 12 power of 180 minus 1 over 0.072 2 over 12 close bracket. Then first we need to solve number that in this small bracket first. So 150 1.006 power of 180 minus 1 over 0.006. Then we solve all of this in the bracket. 150 times all of that number, which is equal to 322 equals to 48379.80. So this will be our S. So the amount in the account after 9 years, therefore the amount in the account after 9 years is RM 48,379.80. That's all for example 1. Next we will move to example 2.
Let's discuss the future value of the ordinary annuity. Example 2. You decide to work for the next 20 years before an early retirement. For your post-retirement days, you plan to make a monthly deposit of Rm 1,000 into a retirement account that pays 12% interest compounded monthly. You will make the first deposit 1 month from today. What will be your account balance at the end of 20 years? Before we go further, how do we know this question use ordinary annuity formula? An ordinary annuity is a series of equal payments made at the end of consecutive periods over a fixed length of time. So, since it has mentioned at the end of 20 years, we will use the formula as shown here. Next, we will take out all the information from the question to make the calculation easier. Given R, which is the payment, is equal to Rm 1,000, small r is annual rate, which is 12%, and we convert it to the decimal, is equal to 0.12. M is compounded monthly, which is equal to 12. T is time period, is equal to 20 years. By using the formula I equals to R over M, we substitute the number, which is 0.12 over 12 is equal to 0.01. And let's calculate the N, where N is equal to M times T, is equal to 12 times 20 equal to 240. So with the value I and N, our calculation will be much easier. Since we had the information that we need in the formula, which is R, I and N, by using the formula of ordinary annuity, we substitute all the information in the formula. S equal to 1,000, close, open the bracket, 1 times 1 plus 0.01, close the bracket, power of 240 minus 1 over 0.01. We'll calculate the small bracket first. So, S equal to 1,000, open bracket, 1.01,
close the bracket, power of 240 minus 1 over 0.01, close the bracket. And then the value of S equals to 989,255.37. Only take 2 decimal places. So the amount in the account balance at the end of 20 years is Rm 989,255.37.
Now, let us discuss the future value of annuity due. So, here is the example 1 that we will go through. Kelly is saving up her allowance and depositing 500 ringgit at the start of every month. How much will she receive after 4 years if it will be compounding at 3% monthly? Before we go further, how do we know that we will use annuity due formula to answer these questions? Remember, annuity due is an annuity in which the cash flow or payments occur at the beginning of the period. So, since it has mentioned at the start of every month, we will use the formula as shown here. Similar to formula ordinary annuity, but what makes it different is the 1 plus I there. Without further ado, let us jump to the question. The first thing that we will do is take out the given information from the question. It will make the calculation easier. So R, which is the payment, is 500 ringgit. The time period is 4 years, so T will be 4. The annual rate will be 3%. Change it to decimal and it will be 0.03. And lastly, the compounding frequency is 12 since it has mentioned monthly there. Done with taking out all the information, now we can calculate the I, which is the period rate, and the N, which is the number of interest-bearing periods. Using the formula I equal to R over M, substitute R and M, which is 0.03 over 12, we will get 0.0025. Same goes with N, which is equal to MT. We substitute the value of M and T, which is 12, multiply with 4, and we will get 48. Now, our calculation is getting easier since we already have the information that we need in the formula, which is R, I, and N. Using the formula of future value of annuity due, we substitute all the information into the formula. 500, open bracket, 1 plus 0.0025, close bracket, open bracket again, 1 plus 0.0025 to the power of 48 minus 1 over 0.0025, close bracket. Done with substitution all the information, now we can calculate. We solve the 1 plus 0.0025 first, and we will get 1.0025. Looking much easier now. Solve the calculation, then we will get the answer, which is 25529.27. I just take 2 decimal places. So, we can conclude that Kelly will receive 25,529 ringgit and 27 cents after 4 years. So, that's all from me. Thank you.
Next, the question tells us Karisha saved 4,000 ringgit per year at the beginning of each year for 3 years and earned 5% interest per year. The question asks, how much will she have at the end of 3 years? So, we have to find the future value of how much Karisha will have at the end of 3 years. Before further ado, we have to take out all the informations given. Since 4,000 ringgit is the payment, so it is our value. As we know, T is the time period. So from the question, T is equal to 3. The compounding frequency M is 1 since the question mentioned per year. 5% is periodic rate, which is I, and convert it to decimal number, which is 0.05. So, we will use the formula of future value of annuity due. By using formula N equals to M multiplied by T, we substitute M equals to 1 and T equals to 3. So, the value of N is equal to 3. Next, we will substitute all the information given into formula of future value of annuity due. We will get 4,200 multiplied by 3.1525, and the final answer is 13,240 ringgit and 50 cents. Thus, Karisha will have 13,240 ringgit and 50 cents at the end of 3 years.